Hello and welcome. In the previous video, there was a slight mistake. I want to correct it now. So for this function, x square plus 5x plus 6, the range is from minus 1 by 4 to infinity. Here I had written 0.25. This has to be minus 0.25, and one more change. So here I had written closed bracket for minus infinity. This is not true, and here this is not true. This is also not true. So it is actually minus infinity to 12.25. This is included. In this video, we'll discuss another method to find the minimum value or maximum value of a quadratic function. In the previous video, so this method is called completing square method. Completing the square method. So we know that if if a is positive, the curve would look up like this, and this point is called the minimum point. This is the minimum value. So here we can say this as vertex point, vertex, and this is the maximum or minimum value. So if this is case a is, when a is positive, this is f min. Similarly, when the curve is looking down, a is negative. This is my vertex point, and this is actually f max. So now let us try to find this vertex point and the minimum maximum value using completing square method. So the idea is let us take the function f of x is equal to ax square plus bx plus c, and what I'll do is f of x is equal to a times, I'll take a common, so this will be b by ax plus c by a. So this, from the first two terms, I'll try to complete the square, right? So x square plus 2 times a is x, b is b by 2a. So if I do this, I can add and subtract b by 2a whole square plus c. So from these three terms, I can write this is a square, this is b square, this is 2ab. So this I can write as a plus b whole square. So x plus b by 2a whole square minus b square by 4a square plus this is c by a. Now I'll multiply a, the whole thing. So this is a x plus b by 2a whole square minus, so if I multiply a with to this becomes b square by 4a plus c. So now I'll write this equation again in the next page. So what we got is f of x is equal to a times x plus b by 2a whole square minus b square by 4a plus c. This is what we got. Right. So what I'm going to write this here is a times x plus b by 2a whole square plus, write this as minus b square by 4a plus c. So in order to eliminate x, if I want to eliminate x from this equation, I have to put x is equal to minus b by 2a. So when I put x is equal to minus b by 2a, this term will cancel. This term becomes 0. So this, for the value of x where the x vanishes, is called the vertex point. This is the vertex point, and this point, this value, after vanishing x, what is left out? Left out thing is minus b square by 4a plus c. This is actually f max or f minimum. This is the same thing we got in the slope method also. Now let us solve a problem. To understand this better using completing square method. So I'll take f of x is equal to same equation. Let us take x square plus 5x plus 6. So this is x square plus 5x plus, so I'll add and subtract 5 by 2 whole square. So whatever is here b, I'll take half of it, minus 5 by 2 whole square plus 6. This is equal to, from these three things, or I can write this as x square plus 2 times x times 5 by 2. So this will not alter this. Again, this is 5x only, plus 5 by 2 whole square. I'm actually completing the square, minus 25 by 4 plus 6. So from these three terms, this is a square, this is b square, 2ab. I can write this as x plus 5 by 2 whole square, plus I'll write this as minus 25 by 4 plus 6. So this is equal to, this is x plus 5 by 2 whole square plus minus 25 plus 24 divided by 4. This, I can write it as x plus 5 by 2 whole square plus minus 1 by 4. So to vanish x, I should put x is equal to minus 5 by 2. What does it mean is, so if I have, since a is positive here, the curve should look up. This, so this point is actually vertex point, which is minus 5 by 2, and this value is actually minus 1 by 4. This value will directly get here, minus 1 by 4. So the range of this function is, since it is looking up, it starts from minus 1 by 4 and goes up to infinity. We'll take one more problem, or before that we can verify in the graph. X square plus 5x plus 6. So this is the point which is minimum. The minimum point is, you can say, it is minus 2.5 and minus 0.25. So this point is actually minus 2.5 comma minus 0.25. Let us take one more example. F of x is minus x square plus 5x plus 6. So what I do is I'll put minus outside, x square minus 5x minus 6. This is equal to minus x square minus 5x minus 5x. So I'll add 5 by 2 whole square and subtract 5 by 2 whole square from the equation. So this will not alter the equilibrium of the equation. So from these three terms I can write x minus 5 by 2 whole square. This is a minus b whole square minus 25 by 4 minus 6. So this I'll take now negative to inside, x by minus 5 by 2 whole square, x minus 5 by 2 whole square, minus into minus is plus 25 by 4 plus 6. So this further I can write minus of x minus 5 by 2 whole square plus 25 plus 24 by 4. This implies minus x minus 5 by 2 whole square plus 49 by 4. So to vanish x, I should put x is equal to 5 by 2, which is my vertex point, and this value itself is the minimum point. So this is f minimum. Sorry. This is actually, the curve is looking down. Since the curve is looking down, this point is actually f max, not f min. It is f max, which is 49 by 4. This point is plus 5 by 2, and this point is 49 by 4, which is 12.25. So this point is actually 2.5 comma 12.25. The range of this function is it is from minus infinity all the way up to 12.25. Beyond this it cannot go. 12.25 is actually included. Let us verify in the graph. I'll put this as minus x square and see this point is actually 2.5 and 12.25. So the range is from 12.5 all the way down to minus infinity. Next videos we shall solve more problems, and we can see how we can solve problems with less time. Thank you.